Motion over time, part two. All right, I ended a little abruptly, I feel, yesterday because I realized that we were missing rotation and we were missing scale and we were missing talking about canceling a motion over time. And we're going to talk about that. So, really, I'm going to write that down. So, uno momento. Unfreeze. Well, for me, for you, it might have been instant. So rotate, scale, and cancel. And I think we should first start with a kind of a broad understanding of how rotation works, because I think intuitively you expect it to work like position, where it's like, I need to rotate maybe 90 degrees, or I need to add like a 90-degree rotation. But rotations are in quaternions, and quaternions are fourth dimensional things, which basically means it's hard to understand what they're doing. So most of the time we work with Euler rotations, which you need to then convert to a quaternion, which I'll show you how to do. Write that down as well. Euler to quaternion. Okay. And most of the time when you want to calculate a rotation, like where you're heading with the rotation, you need to use the forward direction and the upward direction. And if you have the forward and upward direction, you can really determine where you want to look. Like that's pretty much all you need. If you just have the forward direction, you could rotate along this axis because you don't have the up direction. So as long as you have forward and up, you're good to go. Now if you only have forward and you don't have up, you can use the world up and you can get away with that pretty well. But I think we need to see some more practical examples. Now scale really isn't that hard. Could have totally covered scale yesterday. It was at the very end of my day. This is at the very beginning. Welcome. I haven't even had my first call of the day. I'm so excited. So let's go ahead and jump in. And we'll just jump back into our motion over time tutorial world. And there's just so much to talk about. I'm so excited. I do think we should probably mention the canceling over time, because that's pretty easy to see and explain. If you haven't already heard, there's a competition going on. There's the update about that in the desktop editor. Okay, doke. So here we are. And what I'd like to do, just to demonstrate this, is to cancel the rotation cancel the motion. So right now you'll remember that we left off and they go like this. So what I want to do is like cut them off after 1 second of motion, just so we can see them stop. So if we go to our scripts, easy moving platform, open an external editor. That's weird. I did just get an update installed like just a second ago, so maybe I need to restart this. Let's try this one. Open settings. VS Code is selected. Okay. Hit apply. Try that one more time, and then we're going to restart. Open external editor. All right, let me pause. Let me pause the recording and then restart the desktop editor. All right, we're loading back in, and I love that. Yes, be kind to each other. I wish the whole world would do that. I really do. Me and my wife were just talking about how we wish everyone would just get along. Anyway. Scripts drop down, 3 dots, open external editor. Hey yo, have you ever tried turning it off and on again? Is the thing I ask myself all the time. And obviously that worked fantastic. So here we are, and what we want to do is take a look a little bit more into this overtime utility that we added to our world. If you are jumping into this without any context, you really should watch the first one, but I understand it's an hour long. So you can just come into the asset library creator, type in Vidyuu, and then once you get to Vidyuu, you'll see this overtime clock manager thing. And if you pull that out, you get this bag of stuff right here. This that's a terrible name for this thing. But this asset pulls out, and that is the overtime manager, which gives you access to a bunch of easy motion overtime. I do recommend doing the first tutorial, as it teaches you some of the harder overtime stuff, which is this one right here. You can also just pause and read that if you're so inclined to really not watch the last one. But there's a lot of good stuff, like talking about on update. So anyway, back to the easy motion platform. So let's quickly take a look at everything inside of overtime. And you can do that simply just by typing over time dot, and look at, there's three things. We have move to, rotate, and scale to. But if we go back into the move to bag and then click dot, you'll notice there's cancel, get all, and start. I'm not going to talk about get all because I don't really think you're going to need that. I don't use it. It's just like it was there when I was working on it, and I was like, we might as well have this thing. But it returns an array of all currently moving things, like entities in motion. So for some really advanced stuff, you might need that or want that, but I prefer to track all of that sort of data myself. So I would have had a map or an array tracking that data already. I don't want to rely on somebody else's utility. Like, even though this is my utility, I wouldn't want to rely on an external utility to do my like game manager stuff. So, but if you need it, it's there. So the ones that we're concerned with are start and cancel. And if you're familiar with async, you will remember that async returns an ID. And I'm not sure if we've taught this yet, but if you look in here, it returns a number here. That's what that means. And so this returning of a number on an async allows you to cancel this interval. And so we could say something like constant async ID equals, and now async ID is the number that represents the ID of this interval. And then we could come down here and type async dot clear interval and then pass in the async ID. Now, of course, that means nothing would actually happen here, but we could take this one step further and type async dot set timeout, and after a period of time, we can call our arrow function like always. Then let's say we do this after 5,000 milliseconds, so 5 seconds. After 5 seconds, we cancel the interval, so it stops running. We just move that into the curly braces and hit Control save. I realize that I normally write it like this, but because it's a line of code, it makes sense, I think, to do it this way. So we're going to go ahead and comment this out for just a second. Control save. Okay, that's going to compile. And now this is going to do something different than what we're planning to do, but I think it's similar enough that it's very nice to talk about. Give that a moment more. There we go. And world simulation on. So it's going to go for 5 seconds. 1, 2, 3, 4, 5. And notably, this one stopped right at 5 seconds. This one continued going for an extra second because we cleared the timeout, not the motion. So the timeout, if we look at that, just to remind ourselves what, excuse me, not the timeout, the interval, was calling loop. And so loop had already been called, which runs for 2 seconds, which is why one of them went for 6 seconds, whereas this one seems to be timed up pretty close to 5 seconds. I think it's 4.5 seconds, something like that, because it's at 1.5, something like that. But anyway, so this one finished sooner than that one. Okay, I'm going to pause and just try to put good words there. I need to put good words there. So I just want to make sure we're really hammering this home. So you've got async. You get the ID from setting the interval, which is a loop, right? So we're calling this loop on repeat. And by having that ID, we then put it in a set timeout, which after a certain period of time is going to clear the interval, so it stops running the interval. And we did that after 5 seconds, and so the one loop that went longer runs for 6 seconds because the loop is triggered, and then it runs the motion for 2 seconds, and the next loop is triggered, it runs the motion for 2 seconds, and then the next loop is triggered, which is at 4 seconds, because you do it at 0, 2, then 4, and then we're canceling the one that would have happened at 6 seconds. So it runs that third motion over time, which takes another 2 seconds, so that means it continues moving until 6 seconds. I hope that makes sense. Okay, so with that demonstration out of the way, we can now go ahead and delete all of this, because we do want our loop to continue running. So we're just going to delete that, Shift-Alt-F. And now what we want to do is stop the motion halfway through using something very, very similar. And so over time, .move_to and then .cancel allows us to cancel a motion over time. We just need to provide the entity or the number. Oh, that's very nice. You don't even have to provide the ID. You can just provide this .entity as the object you want to stop moving. That is so fantastic. We'll do it both ways. I mean, maybe we don't have to do it both ways, but we're going to do it anyway. Just muscle memory is great. So we'd say constant I'm going to call this the over time ID equals, and if I hover over that, you can see that that's a number. If I hover over start, you'll see the explanation, which says it returns a number here, and right here it says returns number ID that can be used to cancel this move to. And then we want to do that in a timeout just like before. So we say async dot set timeout, parentheses, and then let's go another arrow function, curly braces. The delay on this is going to be half of the loop speed milliseconds. So we go props dot loop speed milliseconds multiplied by 0.5. That way this is never longer than the loop speed, because that could cause some issues. Clicking enter, we can now move the cancel to, and we'll just pass in our overtime ID. Booyah, control save. And so what we should see this do is it moves to the halfway point and then teleports to the end to continue its next motion. Clear and start. So it's going to go halfway and then, oh, whoa. That is different than I would have expected. It's stuck in the middle. How interesting. That is so interesting. I mean, okay, but why? I want to understand why that's happening. That's so interesting. So we're lerping from the... Oh, because the move to uses the position of the thing, so it goes to this position. How interesting, interesting. If you wanted to do, so I like this. This is great behavior because it moves to from the current position. Love that. But if you really need it to start at the start or destination position, we can set up something like this dot entity dot position dot set. So we're setting the position manually. So we're like teleporting it to a position at the start of the loop. And then we can use this dot is moving up, but in reverse. So you'll remember this is the ternary operator, which allows us to say, if moving up, use this position, else use this position. So it's kind of like an if else real quick. But we want it to be the reverse, right? Yeah, we want it to be the reverse of that. So start position, then destination position. Honestly, when you're kind of like going fast like this, sometimes I'm just guessing and checking, and I'm 99% sure this is right. But if I'm wrong, it's just a quick flip-flop, and it's easier to just quickly run in and test it. And so the goal here is to get it to do what I said it was going to do. The overtime stuff, the canceling, that's totally all working, but we want to get it to get that teleporting motion that I had said, because if that was our goal, we want to be able to achieve our goals. So anyway, here we go. Teleports. That didn't teleport. Okay, which teaches us one more thing about position.set, which is we can now see that position.set is overridden by another position.set, because when we call this move to.start, it is immediately moving the position, which means we need to wait just a split second before calling this move to. Which is a little bit tedious. So before we go, I don't want to get sidetracked too much. I just want to quickly demonstrate before we move on from this that you can pass in this dot entity and it will still cancel the motion. So you can use the ID, which is like that, which was pretty easy to use. We're going to delete it though now. Or you can use the entity itself that you want to cancel the motion on, which I think is so fantastic. I love that. That's going to take one moment to compile. 1, 2, 3, 4, 2 more. 2 more? Maybe not? Okay. 1, 2, oh, they're there. There we go. And then, as you can see, it continues to stop just as before. All right, now let's get that teleporting motion working. We no longer need this overtime move to, so I'm just going to delete this. And to get this to happen the very next frame, right? So position.set is happening in the exact same frame as this motion.start. And so we need to say async dot set timeout parentheses, parentheses. And so we're just delaying this code by a singular frame. I wouldn't type 1 millisecond because that's too small. But if we know, I don't know if there's a calculator tool on here, but if you take 60 frames and you divide it by 1,000, that's really what we're going to, which is 6 divided by 100, which is roughly 20 frames, 20 milliseconds, right? 6 over 100, 5 over 100 is 20, so 6 would be slightly less. So yeah, 20 milliseconds should be just about the right amount of time. And so we're basically delaying it by 1 frame so that in the first frame it teleports to the starting position, then it starts the motion. And then we can move our motion over time into the set timeout. And I feel like that got a little out of hand, a little too advanced, but knowing how to get to our goal is important. And hopefully I was able to walk you through the logic train in my brain on how that works. Okay, that's interesting. That's not behaving correctly, right? Okay, why is that not behaving correctly? If moving up, teleport start position. Oh, because I reversed it. These are reversed. These are reversed. Ah, oops. Right? Is that what happened? Control save. Did I get those backwards? I'm now, okay. I'm not sure. Give that 1 more second to compile and start. Oh. Dummy me. I deleted the code that we needed to be able to demonstrate this. Let me copy this real quick. Control C. Control Z, 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 Z. It was, remember this guy right here? Control Shift Z. This timeout is what made it so we needed this position.set. I apologize. I went a little too fast. Shift Alt F. And that set timeout needs to be nested in this other set timeout so that they're all timed up correctly. So Shift Alt F. Okay, let's just read through that to make sure we're on the same page here because I made a lot of changes. So we start by setting the position to be where we wanted it to teleport to. Because you remember, the goal was it's going to start, it's going to go halfway, then it's going to teleport, go back halfway, teleport. And that, it's dumb, but for the demonstration purpose, we want to actually see it happen correctly. And now we've got this.async.set timeout, which is going to create a brief delay of 1, so that's 20 milliseconds, which is roughly 1 frame. So we're going to wait 1 frame after this before we start moving so that it doesn't conflict with this position.set. And so we start the motion over time. And if you don't remember this from yesterday, that's totally cool. Let's just go over it. So we start the motion using the overtime manager. We are moving this dot entity. We're using the isMovingUp Boolean to determine if we want to move to the destination position, if true, or if false, we move to the start position. And we use the property loop speed millisecond from the properties panel to determine how long we want it to take, which allows us to have multiple objects with different speeds. So down here on the properties panel, you can see 1500 milliseconds versus this one at 2000 milliseconds. Then over here, we set our next timeout so that we wait half of the loop speed is what we're waiting. And then when that happens, we cancel the motion to stop it from moving any further, just to show how this cancel motion over time works. And then at the very end, we set isMovingUp to be not isMovingUp, so it flips the Boolean to be the opposite state. Now, I'm thinking this might actually need to move up and into here, into this, this delayed. I'm not sure, but I'm thinking that needs to happen because this set timeout does seem to be referencing this, and this does happen after a frame of delay, whereas the code outside of it happens instantaneously. So I'm worried that that was, excuse me. We should test it, and let's see how to test this. So if we type console.log parentheses, and then in this console.log, we're going to start with a string to describe what we're logging, which is the actual. And so the actual Boolean is the isMovingUp Boolean dot toString. So I thought that would stringify. It looks like it'll be fine though. I think the console.log will handle that for us. And if we hit Control-C, Control-V, and Alt-arrow this down, we can do the goal is what happens before we change it, and then Control-C, Control-V, and then the change is what we've changed it to. And so what we should see printed to the console because of this delay is goal change actual. And actual is probably going to match the change and not the goal, which is why we will need to move the is moving up into this set timeout. Let's go see that in motion. That'll just take a second to compile. All right, there we go. And clear, and world simulation on, and pause. We've got two of these, so you can see the goal is true, the change is false. Oh, it used the goal. I'm surprised. That is very surprising. Oh wait, no, I misread this. So here you can see the goal is true, the change is false, but because there's two objects running the script, we get that 2 times in a row. So then goal true, the change is false, and then we get 2 falses. Yep, there we go, that makes sense. That's what we were expecting. So it's using the changed value that happens down below. Now if we move this up to here, and then we should keep our console logs there so you can see it. Control save, and we'll give that a second to compile. We'll see the new value is the one that we actually want. Clear and simulation on. Pause, and you can see true, false, and it's actually true. Wait. Goal is true, actual is true. My brain is starting to break. Because now they're out of order, right? So now we're getting actual first, which is what we want it to be. And we need to check it to see if it's the goal. Okay. The order is changed. So actual was true, the goal was true. So we got it. And then the actual is true, goal is true. Perfect. That happened like we wanted it to. So we can now delete these console logs, Control X, Control X, Control X. And now it says move to based on the Boolean, and then we change the Boolean inside of the set timeout. Perfect. Control save. So what we should now see happen is this motion. I don't think we have this right, I'm pretty sure. We'll see in a second. Clear, clear, and simulation on. Let's see if that works. Oh, I had that one selected. Stop. Let's try that one more time. World simulation on. There it goes, and then teleport. There it goes, and it comes back to halfway. Obviously that's janky and like not actually something you might, maybe you'd want to do that in the real world, but it does demonstrate how to teleport something, get it to move a little bit, and with that, let's move on. Okay, thank you for bearing with that interesting discovery. So we have now covered canceling of motion in a couple different ways. So I hope that helps. If you have more follow-up questions, be sure to use the Discord, links in the description. We are now going to start talking about scaling, because scaling is just as easy as motion. And then once we're done with scale, we can get into the hard topic of quaternion rotations. And so to do a scale, did I, yeah, I minimized that. I meant to, maybe I didn't minimize. Come on, let's close out of that. Okay, so scale is something that we can do in line with this. Now I want to get this back to our original code because our original code makes a lot more sense and is less complicated. So we're going to stop teleporting it. We're going to just do the motion over time and just do the flipping of the Boolean. We can then delete this whole delayed canceling stuff because we're not doing that. That was just a demonstration. I think it's wise at this moment to very quickly test and make sure it does behave as it originally did, and that we've got our code back to where we liked it. One more, and could not save. That's interesting. All right, but there it goes, and back and forth. Perfect. One more proof. Perfect. Now, I think it would be interesting if we just add a scale to our loop. And we can just do that, right? Over time dot scale to, and we do a dot start just like before. We want to scale this dot entity, and let's check the current scale of this object. We can see that it's 0.51. So let's So let's do something kind of gross, but kind of funny. Um, I think it would be wise to create 2 more vectors up here, Control C and Control V, Shift Alt F to prettify that. And this will be a start scale and a destination scale, just for the demo, right? And then we can create these using new vec3, and we can manually type them in. Obviously, you don't normally want to do this, so we should talk about properties for that in a minute. But for now, new vector 3 is going to be 1, 0.5, 1. And so that's the scale that we just read off the properties panel. And if we copy this down below, Control C, Control V, we can change this and make it a thick boy, like 3, why not? And so then if we continue writing the code here, matching what we did above, we're gonna use the this dot is moving up, and using that we can say if it's moving up using the question mark, what we want to return is the destination scale, or if it's false, we want to return the start scale. We want to use the same duration, so prop types, props dot loop speed milliseconds. And now what we should get is this quite interesting looking motion. Give that a moment there. And world simulation on. And so it scales and gets thicker as it goes up. There's like, that's kind of neat. I mean, that's kind of neat. I could see a place where that would look really cool. So now we're messing with scale. And obviously we're messing with scale on the y-axis. You could mess with scale on the other axes. And there's obviously a lot more ways you can mess with scale. But let's change this up just one more. Like the easiest way to do this is just like we do with distance meters. And then right here, we multiplied it. I mean, that's always an option, but let's go ahead and duplicate this line. Control C, Control V. Let's change this to be thickness. Sorry. And we were using 3, so we'll change the default to 3. Press Control, or we'll call this destination thickness, right? Destination thickness. Control Save. And then we can come over to our code, or to our objects here. And that will happen. That'll create a property in the properties panel. This one, I really liked that way that it looked. This one, on the other hand, I didn't like it so much. So let's just keep it at 0.5 by changing destination thickness to 0.5, which is its current thickness. And then we do need to use that number. So right here, we need to change out 3 with the props dot destination thickness. Press Control Save. Give that just a moment to compile. And then we can test that code and see that this one will not scale, and this one will scale. Let's see, that should be the ideal viewing angle for that. Clear and play. Ooh, that's weird. I did something wrong, apparently, but I don't see anything wrong. Try one more time. I think this is a Horizon bug. It's unable to initialize. I'm guessing something is wrong. We put the number in here, destination thickness. It is a number, default is 3. We changed the number. It says it does have to do with the properties. Let's see if just slashing this off and switching it back to 3 fixes the bug. Control Save. Dun, 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 dun. Clear. We might also just want to leave the world and come back. It's a common problem with Horizon where you have to exit this building scene. All right, yeah, so that is working. And if I let go of that one's working too. Let's see. This seems fine. I don't see any like missing commas or anything. Don't see any issues with this. Control Save. Let's just add it back in and see if the bug immediately appears without changing the number in the vector. Give that one more second to compile. There it goes. Okay, still working. Oh, I know what I did wrong. Ah, easy mistake. Oh, this is a learning opportunity. This is great. I'm glad I made this mistake. So you'll remember that we set the start position and destination position inside of start. That is very intentional. It's because the properties have not been initialized when the class is initialized. So these props don't exist here, but they do exist in start. So we need to come down here to destination scale and then say dot y. There we go. And we're going to change the y component of the destination scale to be equal to the properties destination thickness. There we go. Okie doke. Great learning opportunity. I forgot. I'm supposed to be like purposely putting in squiggles. Like if we backspace right here. Oh no, there's an error. If we hover over it, you can then see what's the problem. It says comma expected. Oh, and then you'd be like, ah, duh, forgot my comma. I'm supposed to show you. I don't know. I'm sorry. I'm trying to figure out how to teach IntelliSense, which is what this is, and I don't make errors that often, so I need to start intentionally adding them. But anyway, there was an error that I did make, and we got to learn from it. Oh, so good, so good. It's a good reminder that we need to make errors sometimes to learn from those errors. Anyway, pretty cool, pretty cool. And let's go ahead and start the world simulation. So this one is going to stay flat, whereas this one's going to get thick. Yeah, wait, what? Ah, it probably lost the value and it went back to the default, so we change that to 0.5. And now we can hit world simulation on. There we go. So this one stays skinny, and this one gets big. Very cool. Totally love that. Very, very cool. Okay. We've now talked about scaling. We've got the scaling working. It's time for us to talk about rotation. And what I want to do is create a counter to know how many times the loop has happened. So we're going to create a new value down here called loop count. Loop count will equal 0. And then when loop is received, we're going to increment loop count. So right here at the beginning, we'll say loop count plus plus, which allows us to increase loop count by 1. And now that we've incremented loop count up, we can utilize that to calculate the current destination rotation. And I think this is just the first one that I want to make to quickly show how to rotate something by an amount. So we're going to rotate it by 90 degrees every loop. And to do this, we're going to go and create, just like we did with the start position and destination, we're going to actually create a start rotation. So start rotation, which is no longer a vector, it is a quaternion. And so we do equals quaternion, and then you remember quaternion, you'll remember vector 3.0 from above. There's a similar zeroed out quaternion called quaternion 1. And quaternion 1 is equivalent to vector 3.0. If you hover over it, you can see the value of a quaternion 1 is 0, 0, 0, 1. And this is what I meant when I said it's a fourth dimensional value. It has your x, y, and z components that you'd be familiar with, but it also has this w component that I don't even know how to explain. So unfortunately, I'm not a good teacher of that. It's the fourth dimension. So if you want to learn fourth dimensional math, I'm sure you can find a YouTube video on it. It's pretty cool, but out of my wheelhouse. I've tried to understand it, and I'm at a loss. So at some point, I'll go back and really study it harder. But for now, all you really need to worry about is how to convert Euler to quaternion, which I'll show you in just a moment. Like after this this section. We're not doing that immediately, but we'll do that soon. Okay, so we've got quaternion.1 filled out for our start rotation, and then just like before in start, we can now say start rotation equals this dot entity dot rotation right there dot get, and that's going to get the rotation. If we hover over that, we can see that it returns a quaternion. We can see anything else about it. You must use the set call to manipulate the current rotation value. Sweet. Okay, so we got our start rotation, and now over here we're going to start our overtime motion. Overtime dot. I'm going to pause there for a second because I read something that I thought was really easy to understand, but I'm like, maybe it's not. So what this is saying when it says mutating the state doesn't change the underlying value is saying that if you get if you get this rotation value, which we're saving as start rotation, and then you change this variable that we've created, it will not change the rotation of the entity. To change the rotation of the entity, you have to use entity.rotation.set, and that's the only way to change the rotation. And that's because we're bridging to C#, which you remember bridge calls from yesterday. So I'm not going to go talk too much about that, but hopefully that helps explain what that little bit was. Okay, so back down here, we're ready to start our rotation. So we're going to say rotate to, and then we need to say what we're rotating, which is this dot entity, and we need to rotate it to we're not going to use is moving up anymore. This time we're just going to rotate it continuously in a circle, and that's how we're going to be using this loop count. And so we're going to say new quaternion. No. Let's see. We take the start rotation. I'm trying to figure out how to rotate the start rotation. So we take start rotation, and then I believe you use multiply. Yeah. So start rotation, multiply, and if we say multiplies the current quaternion, is there any information here? No, it doesn't. But multiplying it by another quaternion? It multiplies the current quaternion by another quaternion, returns the result as a new quaternion. So theoretically then, I haven't done this in a while, I'm thinking you have to do new quaternion, which is actually quaternion dot from Euler. So this is, oh, I guess we're getting into that a little sooner than I expected. So we're gonna create a new quaternion from Euler. So in this case, we don't use the new because we're using a method on the quaternion. And you'll see that this method returns a quaternion, so it's going to create that for us. So this method runs a new inside of it. It's creating a new quaternion for us. That's why we don't have to type the word new. And then parentheses. And then we need to give it a vector 3, which represents the Euler angle, the Euler rotation of XYZ. And so I think we should demonstrate this first before we start rotating it beyond using loop count. So let's type new vec3 parentheses, and then the value is going to be 0, 90, 0. So ideally we're rotating it 90 degrees on the y-axis. And Euler rotations are super easy to understand, right? It's just x, y, z. So creating a quaternion from a Euler is what you're going to want to do most of the time. We do need to tell it how long to take, which is the props.loop speed milliseconds. There we go. And it looks like it needs one more value. What are we missing? Comma? No? What is rotate to upset about? Oh, I forgot to do rotate to dot start. My bad. There we are. Okay, so we got rotate to dot start, and that is now happy. So theoretically, we should see this rotate by 90 degrees, and then it's going to get locked in place because we're using the start rotation and multiplying it by a fixed value. So it doesn't actually go anywhere else. Obviously, if you want to do like a bouncing motion, we could do the same thing we did before. We could create a destination rotation by using this quaternion dot from Euler, and then using the same is moving up question mark, we could bounce between the two back and forth. But that is not our goal today. So let's get a top-down view of this. Go ahead and hit world simulation on, and you can see it rotates 90 degrees, and then it gets locked in place. But we want to keep it rotating 90 degrees. So to do that, I mean, that worked so flawlessly. I was expecting there to be bugs. I'm like actually kind of just shocked. I think we'll take one quick second to click on this and then show you that the rotation value here is shown as XYZ, which this is a quaternion. It doesn't show the W component. I don't know what the W component does, like I've mentioned a million times at this point. What I can tell you is that this will not rotate intuitively. And so you don't want to use these X, Y, and Z values to perform rotation because you do, oh wait, I had a really good demo of this a few years back. Let's see if I can recreate it. I'm gonna use my camera because that's gonna be the best way to do this. Okay, so in the past, you might have seen this if you've been around for a long time, we used to do this in VR, and it was a lot easier to do in VR. So To try to demonstrate this, we're going to grab a piece of paper. We're going to draw a smiley face. Okay, there's our smiley face. Okay, and on the back, yeah, we have another dimension, right? We need a angry. Oh no, we have a different smiley face. Okay, and then I'll note that they're both facing upwards, right? Okay, so we're going to take this and we're going to perform 3 rotations. Right, so the first rotation we're going to perform is a 90-degree rotation. So that's 90 degrees that way. Then we're going to do a 90-degree rotation this way, and then a 90-degree rotation this way. Okay, there's your current smiley. So we go back. No, this way. I gotta remember those. It's actually really hard to remember because they're in 3 dimensions. I live in 3 dimensions. This shouldn't be that hard. Let me write them down so I don't forget them. So we want to do 90 degrees like this. All right, and then it was was that it? We're gonna go with that. So 90 degrees this way. Then it's a 90 degrees that way. So this is top, this is side, and then up, which is like back towards us. Like it's kind of a flipping motion. Okay. Okay. I'm gonna do that one more time so we really locked it in. Rotate 90 degrees, rotate 90 degrees, rotate 90 degrees. Now, let's apply those rotations out of order. Okay, so you have this rotation, and instead of going this way first, we do this way first. Then we do our final one, which was this way, and then we rotate the first one this way. Okay? And what you can see is you're looking at the edge. You're not looking at a smiley face anymore. And let's try a whole different, a mashup of these 3. So like we've shown the first way, which gets you, I think it was like that. And then we do this one more time. So instead we do the side flip again. Then we do the first rotation, which was this way. And then the last rotation, which is this way, which is a different side. And that's the point. When you apply rotations, you expect them to have like an additive property. Like 1 + 1 is always 2. If 1 + 2 is always 3. 2 + 1 doesn't equal a different value. It's the same as 1 + 2. That's kind of what your intuition is. But quaternions, because they're in this 4th dimensional space, which is really 3 dimensions, I know. But when you rotate it, it's getting all janked up. Because as you're applying rotations, it just doesn't work. And so when you try to manipulate these rotation values, you're going to get really frustrated with the results because it's not going to be what you expect. So instead, if you really do need to rotate something 90 degrees, make sure to select the rotation tool, set it to 90 degrees, turn on snapping, and now you've got control over rotating these. And so we can see it's 0, 180, 180. We can then rotate that, and now it's 0, 180, 270. So it rotated 90 degrees here. But if we go back and rotate 90 degrees this way, and then change this to 270, we should get slightly different results, I think. Oh yeah, look at that, completely different result. And that was the point, right? So, there we go. We're back to where we left off. Whew, okay. Enough quaternion mind bending. My brain is a little melted now. Let's get back into code where things make sense and they're not just spinning smiley faces. So we've got this quaternion that we've created from a Euler angle, which Euler angles do behave as we'd expect because they are just simply x, y, z's. What that means is this 90 degrees, if we wanted to keep rotating on 90, we just simply multiply it by the loop count. Loop count. Ta-da! And we're done. It's that simple. And now it's going to continue rotating 90 degrees every single time. Give that a second to compile, and then we'll see that in motion from this perspective. I think will be best. All right, world simulation on, and there it goes. Just continuously rotating. And that's pretty cool. So, but that's not where we're going to stop. This definitely gives you a good understanding of like continuous rotation inside of a loop. And obviously you can take that and change it up. There is one thing to be cautious of, which is 180 degree elements. So if we change this to 180 degrees rather than 90 degrees, you're going to see something probably surprising. Let's see if it behaves unexpectedly. And then I'll explain why it behaves that way. So world simulation on. And it seems to be doing just fine. Oh, this one did it. Did you see that? It changed direction. See that? It's changing direction. Okay. Why is it changing direction? Well, it's actually pretty intuitive once you hear it. So 180 degrees is this. You're not providing an amount to rotate along, like it's not like 180 and to the right or 180 like negative would be to the left. No, it's specifying a position. So when you say I want to rotate 180 degrees, you are specifying 180 degrees. And it could go left or right to get there. There's a 50-50 toss-up. I think the way the code is implemented, most of the time it does continue rotating, but occasionally, like you saw, it does flip the other direction. It's probably like a rounding error. It's probably like 180.0001 or something like that, or maybe 179.0001, so occasionally it flips. Sorry, that would be 999. But anyway, the point is, you're specifying a destination, not an amount to rotate, which is why when you look at the code and you think about, there's the code, this 180 being multiplied by the loop count, it's not, spinning super duper fast the higher the loop count is. And I think it's important to note that this will automatically kind of normalize. So when you get to like 50 rotations, it's still just specifying a destination. It's like it's done the 50 rotations or whatever. Anyway, so it's cool. It's all good. So what I want to do next is I want to change this from rotating to matching a, I just want to catch my breath for just a second, so I'm just going to pop the camera open. Whew. Okay. Quaternions, they're fun. It's a lot. It's a lot. I feel bad for the smiley faces, but I'm kind of done with them. Now it's a 3D emoji. Believe it. Anyway. So we've talked about scale, we've talked about Eulers. The final thing I want to do with this rotation, which I think will be a lot of fun, and so here's our goal. And I don't think you can do this on your own with all the pre-knowledge. And so this is kind of like a big part of this whole series, is getting you a lot more tools and tools in your bag to be able to do this. So I'm going to tell you what we're going to do, and then the question is there a way for you to go do some like extra credit on your own? I'm trying to think before I say, because, okay, well, I'll tell you what I want to do. What I want to do is create a grabbable object, and then that grabbable object controls the rotation of the platform, or where the platform is rotating to. And so we'll just have this grabbable object, you grab it, and then as you move around and rotate yourself, since we're on desktop, we don't have like full mobility like you would in VR. But I think that would be really cool. So I'm wondering if there's a question there, something for you to extrapolate upon. So we grab it, it rotates using that as a reference point. What could you do once you understand the ability to get the forward direction? Okay, once we're done with this, I'd like you to try, oh, but we haven't learned triggers yet. I guess we kind of learned triggers. Here's what we're going to do. The hand one, the ball one, is your extra credit. I want you to go and reference a ball on the properties panel, which we're going to see with the trigger. So you're going to have to reference a different object, and you're going to have to tie it up. So that's your extra credit after I show you what it is. I highly encourage you to do it. I think it'll be a good practice exercise. But there's a few things we need to learn to be able to do that. So number one, we need to know how to add entities to the properties panel. So reference to the entity. So we're going to say grab ball, curly braces. In fact, you're going to do the grab ball. What I'm going to be doing is the trigger. So we want to know, you know what? We're not going to use a trigger. We're going to make our code way simpler than that. So anyway, we need to specify the type of this grab ball. which is a prop type. So if you look through prop types, these are all the different properties you can have on the properties panel, and it's an entity. And I would just avoid all of the array options. Most of the time they don't work the way you'd expect, so just stick with the singulars. If you need a ton of entities specified, that's for a future tutorial or one of the past tutorials. What you want to do in that case is create a data file and add to it. I don't know if I think that's pretty much. I don't think we've really gotten into that yet. So actually, I think we did that in the first tutorial, didn't we? We might have already covered that. Okay, well anyway. Yeah, so you don't want to have an array of entities. Instead, you want to. Sorry, my brain's getting sidetracked, and I'm just like, it's related to code blocks. Like the reason it's there is because this was built upon the code block foundation, and so it's really just outdated. It's not really needed. So anyway, avoid using the array the options, and instead make a data file, and then create a script that gets attached to every entity, and then that script adds itself to the data file. Okay, there we go. I said my piece. So now there is no default when you're specifying an entity. So we can then just hit comma, control save, and now we've got a property for grab ball. And now that you know that, you also know how to access the properties panel. So you should be able to calculate the forward direction and upward direction based off this grab ball, just like what we're about to do. And you might remember we did use forward the other day. Now the thing you need to be careful about is the grab ball is not defined. So when you go to do your rotation inside of loop, which we're going to specify here just as in a quick example, you have to do if parentheses props dot grab ball. What that does is it says, is the grab ball defined? Because if I forgot to fill it out on the properties panel, it's undefined. And I'm just going to show you that real quick because that is going to make it so the rest of your code works. Now what we're going to do is going to be very similar. And we need to know about the most recent player to enter the world. I'm going to just keep adding to this list here. Recent player is going to be of type player or undefined. There we go. And so now that we have recent player, we need to know when that player enters and exits the world. And so we're going to say pre-start, because that's where we connect events. And if I haven't talked about this yet, the reason we use pre-start to connect events is because it happens before start. And it's just a good habit to get into. You could technically connect the events in start. Like connecting can happen anywhere. There are instances where that's what you want to do. But the reason we want to be in the habit of using pre-start is because if you have custom events and you connect them in start, but you send them in start from another script, there's a possibility the event will not be received. Whereas if you put it in pre-start, pre-start's guaranteed to connect all of those before it runs any start methods. So that's why you want to be in the habit of using connect code block event or any of the connect events in pre-start. Okay, so this event is received on self. All entities / components receive the player enter and exit world events. So this .entity, the code block events with an S, has a drop-down list for all the events that you can get. Many of these are specific to like when you're holding an item, when you are using a trigger. There's a bunch of like things that don't happen. But anyway, the ones that we're concerned with do happen on all components, which is player enter world. There it is. And then we want to use a arrow function, which has the player parameter inside of it that entered the world, arrow to the right, curly braces. And we need to create our local player enter world and player exit world. I'm going to finish writing both of these lines using Control-C, Control-V, and changing this to exit world. There we go. And now we need to create the local methods for these, which I will put at the bottom right here. So we have player enter world. So this is our custom method, which has the parameter player, which is a player parameter, curly braces. And I don't know if I've said this in a video yet, but you want to get in the habit of clicking enter as you're typing as quickly as possible. Just reduces the key count. It also auto imports things like player if you haven't already added that to your import line. It's just really nice. So make sure you're getting in the habit of clicking enter as you're typing. Control C, Control V, and now we can change this one to exit world. Has the same parameters, so that's all good to go. We'll come on up here and change this to player enter world, so that connects to our local method. We pass in the player parameter that we received. I like semicolons, so add one there. And we do the exact same thing right here. Player exit world, parentheses, player, semicolon, voila. Now that we have that done, we can come down here into player enter world. We want to use the most recent player that enters the world, so we say recent player equals player, and like that, we are done initializing our recent player. There is good coding practices to handle the bugs before they happen. And in this case, if the player exits the world and the recent player is this player, we need to set recent player back to being undefined. There we are. And this just prevents us trying to access the player while they're not in the world, because that won't happen. It's just going to throw an error to your console. And so one thing you're going to have to start thinking about is what could go wrong. And that's something I've had to build an intuition over years of actually making mistakes. And as you make mistakes, you start building this intuition up. But if you can try to think like, how could this not work? What could go wrong? You'll start being able to preemptively think about this type of stuff. Okay. Next up, we now have the player. So we're going to go and type if parentheses, just like we were going to do with the grab ball, we can type player enter world. Oh, sorry, recent player is what I was supposed to use. So if the recent player is defined and it's not undefined, we can then use that. So I kind of want to go through this if statement just one more time. So if is like looking for a true or false value, right? And right, it's looking for a true or false value. But there's just some like history you need to know about JavaScript and TypeScript, which is a superset of JavaScript. For now. In 5 years, that might not be the case. But sorry. I love tech and news and stuff. So I'm just like, exciting stuff. But if is trying to make sense of whatever you put inside of it. And JavaScript is trying to do its best to never break. As breakable as JavaScript is, it's trying not to all the time. And TypeScript does a really good job of that by always checking for types. And like that's why I love TypeScript. TypeScript's my favorite language. And so when you pass the parameter in, the if statement's trying to make sense of it. It's like, what is this thing that you're passing to me? And so for a player, it's a JSON object, kind of. It's a complicated bag. It's a complicated bag is a great way to describe a player. There's so many levels to that in my mind. It's a good joke. But anyway, so the if statement says, wait, is there a player here? And if there is a complicated bag, it says, you can pass. There's a thing. But if there's not, it's like, this is undefined. There's nothing here, right? And we've specified that. We said it is player or undefined. When we defined it, just like real quick, popping back at that code. Right here at the top, when we define it, we say it is player or undefined. So we've specified what it can be. Now, there are some cases that you need to watch out for because this if statement is trying really hard to make sense of whatever you put in it, and TypeScript will let you put a lot of stuff in there. So one thing you can put in there that I mess up with all the time is arrays and numbers, because you might have a number value that's a number or undefined for whatever reason. I think I've done that once or twice. I wouldn't recommend it, but you can do it. But 0 represents undefined or false. It doesn't represent undefined. It represents false. It's considered a false state. So when you pass a number into it thinking, oh, just verify that this number is real for me, it's going to say, well, that number is 0. This is a false value. And so in some cases, you need to go a step further. And in this case, we will demonstrate that by just actually writing that in and saying if recent player triple equals undefined. And what that does is it very clearly says, I really want to just see that this is undefined, or in this case, we want to make sure it's not undefined, right? So not equals undefined. And so then anything in this if statement has verified that recent player is a player. And so with numbers, you might do that. Arrays is another one that I get stuck on. If you have an empty array with no players in it, so imagine you're like adding players as they enter the world and exiting the world, or entering a trigger and exiting a trigger, you might check that array to see that it's valid. Honestly, I guess an array with nothing in it kind of is invalid, but it might have other code in that if statement that needs to run, and then it doesn't run, and you're like, ah! So in that case, you want to just like say if array does not equal undefined, just like what we just did there. So anyway, I thought it was a good moment to just pause and talk about how that if statement is working. And so you'll see in a lot of places, the code is like TypeScript and slash JavaScript. It really is trying to make your code work. I think another great example, this is the console.log, where you're able to pass in number values and like the Boolean value we did earlier. And yeah, so okay, cool, enough said. Sorry, that was too funny. All right, so we got our player enter world. We're setting our recent player. We've checked that it's not undefined. And now we can do our rotation. And we're going to just move this rotation up. There we go. I'm going to clean this up by deleting some of the extra space. And now we've got our start rotation dot multiply, except we don't want to keep rotating in a circle anymore. Now we want to rotate based on the player. And this is where we're going to use what's called a look rotation. And so if you type quaternion.look rotation, this is going to allow us to create a new quaternion based on the forward value and the upward value provided. So what we're going to do is type in recent player dot forward and then dot get, which needs parentheses, and then comma. And then we need the upward, which we can do recent player dot up dot get. And now we've gotten the forward and the up of the player, and this block will rotate to match the player's forward and up. So yeah, I mean, that is very quickly how it's done, but why we do it that way, it wasn't done. Clear. World simulation on. There we go. So now it's not rotating at all because there's no player defined, right? So it needs a player. We jump into the world. Now there's a player. And look at it. They're rotating strangely. I mean, if I look up, is it looking up? If I look down, does it look down? I think it's using my torso, if I'm not mistaken. So we should be seeing it rotating here. Yeah, it just rotated a little bit. If we turn this way, it then should rotate. Yep, there it goes. And also remember that it's changing the destination rotation, right? So what that means is it's not happening instantaneously, it's happening after a delay. Let's make this instantaneous by using onUpdate, which you'll remember from yesterday's tutorial. So we're gonna create a new method just like yesterday. So this is good muscle memory practice from yesterday. Delta time, colon is a number, curly braces. So we're creating an onUpdate, which has the amount of time between each frame. We want to do the rotation inside of onUpdate, so we're going to move this down using Alt arrow key. I'm going to clean up the spacing so it looks pretty. We're then going to Shift Alt F to beautify it. And then we've got this set up, but we need to connect we need to connect onUpdate. So just like we did up here in pre-start, we're going to add a connection. I'm going to do this before player enter world and player exit world because I want to think about these in the order that they would chronologically occur. So we're going to say connect local broadcast event. The broadcast event, you'll remember, was stored inside this world. And world is, are you going to tell me? Well, it's a class that we can access. It's capital world. Notice that there is a lowercase world. I just wanted to quickly point that out because sometimes I get stuck looking in lowercase world and I meant to look in uppercase world. So if you start by typing in uppercase W, you'll get access to uppercase world. Lowercase world has a different set of things in it that I think we might have talked about yet, might not have. But anyway, we'll get into that in more tutorials later. So anyway, so world, I had to click enter to import it, and then dot onUpdate, and that's the event that we're using. So that's a broadcast event. You can see that here. It says an event that broadcasts. It says local event here. So that's why we're connecting a local broadcast event. All right, so we click onUpdate, and then we just create an arrow function just like before. So arrow, curly braces, and we want to call onUpdate. Technically, if you don't need delta time, you don't have to fill out the payload here. and you don't have to fill out this parameter, like if I hit Control X, that's totally gonna work, and it's faster to write. If you want to code like that, by all means. For me though, I like to have it filled out because I might need delta time in the future, and it also just looks a little bit more proper, right? Like on update should have a delta time. So I'd rather it be there than not be there. And so you remember delta time was stored inside of a payload. So we create the payload colon and then the JSON object that stores the delta time, which is a number. And then that can be passed in as a parameter into onUpdate using payload.deltaTime. Shift Alt F should pretty, it's already pretty apparently. Control S to save. And like that, we now have rotation happening instantaneously. So whatever the player is looking at. But I want to take this one step further. And instead of using just the player's general forward, which I believe was using the torso, let's use the head of the player. And so if we do recent player dot, you'll notice that there is foot, there is, we should see head, there's left hand, there's right hand in there somewhere, there it is. But we're gonna go ahead and use head. So head dot forward, and we'll add that in right here. Recent player dot head dot forward. And so each of those different body parts also has a forward direction and an upward direction, which means if you're using a VR player, you can use their hand to control this, which is also pretty cool. I would recommend what we're gonna do, or what I've assigned to you as homework, which is to use a grabbable ball object, and that will give the VR player something to hold on to, which kind of makes sense. It feels a little like one of those games from Zelda Breath of the Wild where you kind of like hold the thing and, you know, I think you know. So anyway, we're gonna go ahead and world simulation on. Jumping into preview mode is gonna start rotating it, so previewing now. And we can see these look fine, but as soon as I rotate, I'm on the wrong one. There we go. This one doesn't seem to be rotating. This one definitely is. Yeah, that one's definitely rotating. Right? I'm very confused. Then that one started rotating again back. What the heck? Let's check this out. On update, if recent player does not equal undefined, overtime rotate to, look rotation. Let's see here. Let's see here. That seems strange. Didn't seem like it was happening instantaneously, but I was moving my heads. Oh, right, it's a VR, or it's a desktop. No, I'm on the wrong one. Why isn't this one moving? Why is that one clearly is moving, where that one's not? And it almost looks like it's running the old code because it's slow. It's slowly rotating. That is curious. And then this one just flips back. Is there something else in here I'm missing? Rotate to is only called here. I'm kind of wondering. Head forward dot get, up dot get, look rotation returns the rotation. Oh, I see now. We're using rotate to dot start, which is a rotation over time. We want to rotate instantly because we're back in on update. So we say this dot entity dot rotation dot set. Laha. Laha. Oh my goodness. I am going to change one thing here because I think there's a learning opportunity I'd like to build upon. So we're going to cut that. I use Control X, and then I can type constant player head rot. The player head rotation equals this rotation. So we've now saved the player head rotation quaternion, and then we can type it in here. And you'll see why that's important in the next step, but it's also just more readable, right? Like this is a lot easier to read that we're rotating to the player head rotation. And making readable script is literally half the battle because you want to be able to read your code later. When you're writing literally 10,000 lines of code sometimes, you need to be able to read your code when you come back to look at it. So readability is very important. Go ahead and hit clear, world simulation on, jump into play mode, and now we're getting it. There's that instant motion that we were looking for. If I jump on here, I can't even jump on it because it's literally looking towards my head. But yeah, perfect. And you will notice that the avatar rotates slightly slower than the, like if I rotate, it takes a second for the head to rotate to face. See how that rotates in time? Yeah. That's neat. That's really cool. Cool. That's working out great. So, the problem was, though, it was upside down. And that's another reason I wanted to create this player head rotation, was so that we could calculate a destination rotation. And we can do that by using dot multiply again, and multiplying it by a quaternion dot from Euler. And parentheses, we need a new vector 3. And then we need to rotate it 180 degrees on one of the axes. I just don't know which. So what I like to do when I don't know which is just type 180, 0, 0, give it a guess, give it a whirl, see if it's right, and if it's wrong, we'll just twirl. Okay, that was dumb. But anyway, clear, 2 more, and 1 more. There it is. World simulation on. So this is perfect. Now when we jump in, we don't want to obstruct it, right? So now it's facing upright as long as I'm upright. But as soon as I look down, I fall off. And so it's like almost a game in and of itself to stay level, because as soon as you become unlevel, the thing can push you off, which is kind of exciting and fun. Yeah, that's really cool. That is really cool. I really like this. I really like that. So good, so good. Okay, stopping that. But yeah, so what you can see we did there is we got it right first go. I would have guessed this one next at 180, but we knew it was 180 degrees off because it was upside down. So yeah, simple as that. We just multiplied it by this new vector Euler. Now the next thing to note here is that you're going to be going in and using this grabbable ball or grabbable object or whatever it is that you're going to make grabbable. I imagine using the same shape means you don't need to do any 180 degree multiplication. And then if you go to shapes, you can pull out, where was that pyramid? Here it is, pyramid truncated. And then with this pyramid truncated, we can change the scale to be like 0.1. Since we haven't talked a lot about, let's go to 0.2. We haven't talked a lot about horizon systems and stuff. This is actually half scale, right? And then let's move this to 0, 0, 2, up by 2. There we go. So that's right in front of the player when they spawn in. Let's actually move that down to 1 and 3. There we go. And so the idea is we've just created this object, or this entity, and we've got it positioned, but it's not currently grabbable. So if you look at the properties panel, there's a lot here. Like we can change the color. I don't think that's something we've talked about yet. So you can select a color. You can change the tint strength, which is what makes the color get applied. So now it's purple. And then you can also select a texture. I've got quite a few textures. Let's see. Is there a good one in here? Like bleached log. And now if we look at it, now it's a textured tile. Technically we could apply that. The point is I just wanted to show you that there's a lot you can do to in this properties panel. And in addition to that, there's also motion, and we can say make it interactive. We can then take that motion and make it grabbable is perfect. You could change it to be grabbable and have physics. We're not going to, but you could add physics to it. And then you also need to know that it's important to name these very good names, right? So this would be the reference, or the rot reference. And you might call this the purple rot reference. Purple rot reference. And imagine you have one that's purple and one that's not purple, right? So maybe this one here, you go down to the grabbable ball and you reference the purple rot reference, but this one references a blue rot reference. And then you could change the tint color of this to also be purple so that it's clear that that one manipulates the purple one, right? Boom. Select a texture. I don't know if it's going to be easy to find that same one. Should be right there. Oh, wrong one. I don't think that even looks good. These aren't custom shapes, so they're not as pretty. Bleached log. Oh yeah, that's okay. It's not perfect, but anyway, the point is you get this sort of correlation, and now I leave it to you to go in and manipulate the code to utilize that in your in your world. Give that a shot. I would love to see how that goes. If you have any questions, you can join us in Discord. I think that's where we're wrapping today's little part 2 of Motion. Thank you so much for joining. I hope this is helping out. I would love to hear in the comments. I'd love to hear on Discord if it is helping. Seriously, need to know. I appreciate those of you who are commenting. Thank you so much. It does help because I want to make sure that we're making good content. It's hard to tell if I'm doing a good job. So I'll keep trying. We got more to come, so stay tuned and happy creating. Bye for now.